Good evening. My name is Noah Utes, and I'm a senior studying biology. Tonight, I have the honor and privilege of introducing our next speaker, Mr. Mark Mills. Mark Mills is a senior fellow at the Manhattan Institute and a faculty fellow at Northwestern University's McCormick School of Engineering and Applied Science. A co-founder of Digital Power Capital and strategic partner with Montrose Lane, he earned a degree in physics from Queen's University, Canada. Previously, Mr. Mills worked as an engineering scientist in the fields of defense electronics, fiber optics, and microprocessors, where he holds several patents. He served in the White House Science Office under President Reagan, and he has testified on energy issues before Congress and numerous state agencies. He is the co-author of The Bottomless Well, The Twilight of Fuel, The Virtue of Waste, and Why We Will Never Run Out of Energy, and author of Work in the Age of Robots, Digital Cathedrals, and most recently, The Cloud Revolution, How the Convergence of New Technologies Will Unleash the Next Economic Boom and a Roaring 2020s. Please join me in welcoming Mr. Mills to the podium tonight.
Thank you for that, and thank you to our hosts at Hillsdale for inviting me, for the honor of joining you, and thank you for coming to an evening lecture. I think there's probably been lots of jokes made about evening lectures, after dinner lectures, after drink lectures. So I'm not good at jokes. My wife said never do jokes. I'm not doing jokes. But you can wake me up if I fall asleep, since it's past my bedtime. So I have an assignment. I was given an assignment when I was invited, which I was flattered to be invited. Again, it's an honor. It's a great institution. But the masters of this great college told me I didn't get to choose my subject. I have to answer a question, which is the title of the slot. Is environmental justice good for the environment? I could give a simple answer, and not a facetious one. Yeah, of course it is, in principle. But whether or not it is in practice depends on the means to achieve such justice. And I can state the obvious. The evidence today suggests quite firmly that it's not. I mean, justice is, in general, a notoriously complicated thing to achieve. It necessarily begins with facts about reality. So I want to talk about some facts. The realities that constitute the nature of environmental impacts and what we can do about them are anchored in really two domains, economics and physics. I'm kind of biased. I play economist on TV, but I was educated as a physicist. I do enjoy making fun of economists, mostly because their forecasts are serially wrong, and the physicists do a little bit better job with forecasts, which is not always a good job, but generally better than economists. Economists' models fail to predict the past, which I think is a problem. But some of my favorite scientists are economists, so I quote several of them prominently in my book, so I'm not universally abhorrent of economists. But when it comes to environment, environmental impacts, environmental justice, how we can mitigate inevitable environmental impacts from civilization is totally dominated by money and machines, what we can afford, and what kinds of technologies and tools we have. So let me first address the features of environmental justice in this physics domain. I'll turn to the economic realities in a minute. The macroeconomic case is essentially the one I make in my new book, but let's start with the physical domain. And the specific example of the technological reality that's, to use that phrase that's become popular, inconvenient. It's a reality that illuminates how the current focus of environmental justice warriors is misguided. It's even dangerous. So, you all know, policymakers and pundits all over the world, they're pretty eager to ensure, even to mandate, that every citizen drive an electric car. I don't have to explain the motive. I doubt there's a human being in the world, never mind in this room, that doesn't know the motive. And we live at a time when just one topic, the climate, has assimilated everything about the subject of the environment. So without regard to economics, let's start with a physical fact about electric cars. The battery in one electric car weighs about 1,000 pounds. Most people don't know that, but as soon as you say it, it's not that surprising. The important collateral information about that fact is that in order to fabricate that battery, somewhere on this planet, something on the order of 500,000 pounds of materials have to be dug up, moved, and processed. That's about 1,000% more physical quantity of materials than an internal combustion engine car uses over its entire lifetime of operation. That's just a reality locked into the physics of the materials in the universe that we live in. It's not an artifact of failed engineering. And virtually all of that mining activity to make that one battery, 500,000 pounds per car of materials moved to make one battery, most of that mining activity takes place outside of America, often in increasingly poor nations. That's because the United States has been a pretty hostile place to try and open up a new mine for quite a few decades. So if you think about the challenge for America, first we know, as a, again, fact, that the United States today is dependent on importing minerals of these kinds for most of our needs. 17 key minerals, we're 100% dependent on imports. We are dependent for more than 50% of the minerals we use for about 25 other key minerals. So the quantity of minerals required, we're just sticking with the car for the moment, mined in other countries, and you think about this supply chain, this upstream total fuel cycle, you might reasonably ask, how are these mining and mineral realities considered in the calculus of so-called environmental justice? And of course, the rub is, it's not just the electric vehicle. Every technology, everything, all services require technologies, and all technologies, all machines require first starting with mining something from the earth and then processing those materials into a form that's different than found in nature to make those machines. Every product and service takes as a straight line back upstream somewhere to where minerals are dug out of the earth by people using heavy equipment, sometimes just shovels, and in some countries, children. Mining, as you probably know, is one of the world's, in fact, maybe the world's oldest industry. And therefore, and maybe not surprising, what we now call environmental awareness also is an ancient subject area. The first writings about the environmental effects of mining are found more than 2,000 years ago in a book by the Greek physician Hippocrates. All of you know he gave us the Hippocratic Oath. Society has had to contend with the challenges of extraction of resources from the earth for all of recorded and before recorded history. So that's relevant in the context of the Great Reset, the one that's imagined by the World Economic Forum and their fellow travelers. I think we're not supposed to say Great Reset anymore. Is that what I heard? Is that a verboten word? But they call it the Great Reset. That reset, and of course this is not me describing what they say it is essentially monomaniacally focused on a transformation of our energy systems. Our capital systems, yes, but they want to transform our energy systems because they're not bending to the manner in which capital markets are treating energy. So it's not just about cars. And by that, what they mean is they want the world to abandon the use of all hydrocarbons, oil, natural gas, coal, that today supply over 80% of the world's energy and roughly 98% of all transportation. So in their imaginings and in their mandates, that's all going to be replaced soon, quickly, with solar and wind machines that today provide about 3% of the world's energy. So you could set aside this, and it's a lot to set aside, but set aside the destructive economic fallout from that kind of transformation. The critical physical and environmental fact is that the solar and wind machines are just like batteries, the electric cars, in terms of their primary resource requirements. In order to replace an identical quantity of energy delivered to society using wind and solar, that requires mining and processing far more minerals, not a few more minerals, but 400 to 4,000% more minerals, depending on the kind of mineral, to deliver the same unit of energy. And those are for the minerals, the exotic ones and the common ones, from the obvious lithium, but cobalt, nickel, copper, manganese, zinc, the periodic table, basically. In addition, building solar wind machines, machines that capture diffuse sources of energy, the sun and wind, also entails an astonishing 1,000% increase in the use of common materials, concrete, steel, and glass, to deliver the same single unit of energy. I can give you sort of a visual example of that. It's maybe an obvious one, and some of you may have seen wind farms now because they're proliferating all over the world. So replace the energy output from a single 100 megawatt natural gas-fired turbine. Maybe you've never seen one. They sit in a building about the size of a residential house and produce enough electricity for 75,000 homes. To replace that one gas turbine, you need 20 wind turbines, each about the size of the Washington Monument, occupying a land area of about 10 square miles. Building those 20 wind machines requires some, remember we're talking about 75,000 homes. Building those 20 wind machines requires some 30,000 tons of iron ore, 50,000 tons of concrete, and nearly 1,000 tons of non-recyclable plastic, fiberglass for the turbine blades. You could go solar. It would use less land, about 1/3 the land, but it actually uses more of concrete, steel, and glass than the wind turbines. And then if you want those episodic sources of energy to be used as primary power, which is the vision in the Grand Reset, you need energy for days and weeks, not just day-night. You'd need to build twice as much generating capacity, which obviously arithmetically increases the land and material use. You need the extra capacity, of course, to meet peak demand when demand is there, but also to generate extra energy when the sun and wind are available to put into storage, which of course means that that 100 megawatt wind farm, as my example, also has to have 10,000 tons of Tesla-class batteries to store the electricity for when it's needed. To give you a context of how this scales globally for the imagined transformation of our energy systems, the energy transition that the great resetters want. If you manufacturing the quantity of just grid-scale batteries, never mind the wind turbines, batteries for cars, but just the grid-scale batteries to store energy if we become a solar wind-dominated grids globally. Manufacturing that many batteries would require a quantity of minerals to be sufficient for 500 years of mining to make all the batteries in all the world's smartphones. We have enough minerals for the smartphones. Finding enough minerals in existing mines for all the batteries exists in the Earth's crust, without doubt. I'm not a end of minerals guy. But we do know this. The known reserves of almost all the key minerals, including common ones like copper, are less than what would be required to build the energy transition vision. Not the known mining capacities. Those aren't even close. The known reserves. Thus, the imagined reset of a global energy system, if it were to happen, would bring on the world an immediate, not a future or theoretical, but immediate and unprecedented expansion in mining. It would constitute an environmental disruption greater in scale than any in history. It would be one targeting in the main people living in the most economically challenged nations with pristine ecosystems that are so far minimally regulated. If one were prone to mild hyperbole, which I'm not, most of the time, you could say that this great reset would unleash a kind of mineral apocalypse on the world, impacting mainly poor nations and poor people. So think about that, and then think about the definition of environmental justice as envisioned and codified by our regulatory state. The EPA defines it this way, and I quote, "The fair treatment and meaningful involvement of all people, regardless of race, color, national origin, or income, with respect to the development, implementation, and enforcement of environmental laws, regulations, and policies," end quote. As they say, the devil's in the details. How one defines words like fair and meaningful, and especially all people. If we're going to be honest about environmental justice and speak about it broadly, it would be both incomplete and immoral to ignore exactly how people everywhere are impacted by these kinds of visions and plans. I'm not the only one observing these challenges. The United Nations, in fact, the OECD itself, European Union, studies in the technical and environmental literature that rarely bubble up to the general news media are rather common. In fact, I'll give you one example. Australia's Institute for Sustainable Futures. By its title, you know what they study. They cautioned that a global gold rush for energy minerals to meet ambitious reset plans would take miners, and I quote, into some remote wilderness areas that have maintained high biodiversity because they haven't yet been disturbed, end quote. There are cases of child abuse and labor abuses in mines all over the world in these developing nations. In the Congo, for example, where 70% of the world's raw cobalt originates, they notoriously have children literally employed with shovels and bare hands mining the ore. In China, hardly what we would label as an exemplar of environmental and social justice, is not only a major player in mining energy minerals, it's also the dominant global player in the big chemical industries that process and refine them into forms that are useful. What this all means is that building and buying electric cars or solar panels here involves exporting environmental challenges elsewhere, not least exporting the carbon dioxide emissions, with some irony, from all the associated industrial activities. China, it bears noting, burns coal for 2/3 of its electricity. It is in fact clear, at least it is in the technical literature, that a proper full life cycle accounting of the carbon dioxide emissions from battery fabrication would radically reduce the putative emissions reductions from driving an electric car. In fact, in the likely future, based on what's in the technical literature and we know about geophysics, the emissions from fabricating an electric car come close to or likely will wipe out all the emissions saved by not burning the gasoline. In fact, in a lot of scenarios that are realistic, not fanciful, electric vehicles widely deployed would increase global carbon dioxide emissions. So in the face of this kind of sort of environmental reality or technical reality, the advocates of the Great Reset, when they pay any attention to these issues at all, and it does happen, they point out that technology will get better. Well, yeah, I agree. I wrote a book about that. It will. It's going to get a lot better. All technologies get better, including those associated with hydrocarbon technologies. But the resetters want the world to spend trillions of dollars building more of the energy systems that exist now, not those that might yet be invented that are far better. I'm going to switch from negative to positive because I think a faith in technology that they have is well placed. But the resetters are focused on the wrong technologies. What we should be focused on is the macroeconomic promise of a great technological reset, one that will raise the wealth of the world, one that will come from revolutions in all the domains of the technologies that use, not produce, but use energy. That's essentially the thesis that I mapped out of my book, the Cloud Revolution. And the subtitle that you heard in introduction summarizes my thesis. It's not complicated. I'm stating as a fact, which I purport to prove in some 400 pages, that technologies, the convergence of new technologies will unleash the next economic boom and a roaring 2020s. Of course, relevant to the energy visions of the Great Resetters, any broad economic boom will increase overall energy demand. This will make it important, in fact, to have more of both the existing and new kinds of energy systems. But relevant to my Hillsdale assignment, an economic boom will do far more to bring us closer to actual environmental justice than what's imagined by the World Economic Forum with their unachievable energy reset goals. It's a truism, but it's worth repeating. As soon as I state it, this is not in dispute. The fact that so many people live so much longer and more comfortably today compared to any time in history is entirely the result of technology progress. It's technology that gives us the gift of protections from the predations of nature, whether it's everyday things from heat and cold, which used to be difficult to insulate ourselves from, and pathogens, protections from episodic, but the obviously hard to predict disasters from nature and pandemics. The last, to use a technical term, would be no duh. What a year. Technology-driven wealth expansion is the primary force that will bring us closer to environmental justice. Wealthy economies and wealthy people have the luxury of excess capital to spend on things other than mere survival, including and especially on safety and environmental protections. There's a reason that the environmental movement and the associated regulatory systems we've created are so recent in history. We are far wealthier now. Consider the benchmark as a benchmark to sort of calibrate all this, marked from, say, the 1920s. And I have a reason for choosing the 1920s, which I'll get to in a minute. America, since 1920, has seen average lifespan increase by 30 years. And per capita wealth in real terms today is 700% higher. That didn't happen because of one technology or one invention or one entrepreneur. It happened because of the emergence of, as you know, myriads of new products and services. And importantly, it's not just the products and the services, it's the pattern of that revolution that's predictive for our future. Progress can be mapped out, I believe, in terms of the three foundational domains of technology that make civilization possible. Those are, first, our means for accessing and propagating information, of course. Second, all the various and ingenious machines, including those that we call the means of production. And third, the kinds of materials that are available to fabricate everything that exists. If I name the iconic examples, you see how they fit in the buckets. The iconic products that in these three core technology spheres in the 1920s would be the telegraph, the telephone, radio, the electric motor, automobile, and airplane, synthetic materials like polymers, gasoline, and pharmaceuticals. And relevant for my story, which again, I predict in my book, but I'll highlight here, of the 2020s, it's critical to note that all of the technologies that blossomed and propelled the 20th century starting in the 1920s had all been invented far earlier. The key fact about the constellation of innovations that emerged in the 1920s is that they reached useful maturity around that time, and they reached useful maturity contemporaneously. That combination is incendiary. But now, in the world we live in today, the prevailing view from economists in particular, my favorite discipline, is that what we've witnessed since the 1920s is a one-shot happenstance. The new normal, we're told, is a future of slower growth. If that were to be true, then we will see increasing preoccupation and conflicts over wealth distribution, rather than ensuring that the broad expansion of wealth is available for everyone. The new normalists do acknowledge that there will be new technologies, and many of them, they say, will create some market disruptions to news. We've seen that, to education in some respects, but mostly in entertainment, finance. But none of that, we're told, will bring back the kind of booming productivity and broad-based growth that we saw in the past. Instead, the main effect, they claim, will be a handful of winners, greater wealth disparity, and systemic job destruction. So again, I beg to differ. That's what my book's about. I believe the evidence is pretty clear that we're on the cusp of another rare, contemporaneous efflorescence of technologies, and it's happening in exactly the same three key domains: information and machines and materials. The same domains that ignited the world, in the United States in particular, in the 1920s. If this causes America's GDP to grow each year, on average, by 1 percentage point only more per year through 1930, that would generate surplus wealth cumulatively in the tens of trillions of dollars over the coming decade. So you have to briefly acknowledge the obvious. I know that wealth doesn't solve all problems. It's another truism about human nature. It doesn't end wars. It doesn't end malfeasance. Technology can't cure stupidity, last I checked. It can make us smarter, but could be some very stupid things are done. But prosperity does go a long way to ameliorating many of the intransigent problems that have plagued humanity for all of history. And it's a kind of virtuous circle. As technology creates wealth because of productivity, that wealth enables the greater use of beneficial technologies. That's where higher real wages come from. That's where better healthcare comes from. And of course, that's where a cleaner environment comes from. The three sort of key au courant topics of our era. To borrow a word from the computer culture, a reboot is underway in each of the three core technology domains because of innovations, again, that have already happened and that are now reaching maturity. Obviously, the question in your mind would be, it wasn't mine, okay, what exactly are those technologies and what are the indicators for a roaring 2020s? So we need an entire syllabus, not one lecture, to cover that. So you'll have to read my book. But I hope you do. Well, I can summarize iconic examples, because most of them, to use the expression, are hidden in plain sight. Start with the cloud, not Google, but the architecture of the cloud, which is an information infrastructure, the likes of which the world has never seen, in fact, either in scale or in character. It's the biggest infrastructure humanity has ever built. And it's as different from the internet as the internet was different from telephony. The cloud's not a communication system, it uses one, but it's an amplifier of productivity and innovation. The cloud is, in fact, and this is the key, is increasingly woven in every fabric of our society, not just impacting entertainment and news. Those impacts are not trivial, but it's beyond that. It's synergistically expanding and improving, also because of revolutions in machines and materials that are going on contemporaneously. In fact, if you measure the cloud's progress in a metric of merit, which is, in computing terms, how many logic operations, how many computing operations can I buy per dollar? We know that the famous Moore's Law is what took computers from rooms this size to desktops. The cloud is accelerating at a rate, roughly, in economic terms, 10 times faster than Moore's Law. I could do a whole separate exploration of what's gone wrong so far with some features of the cloud, like the power of the tech titans to ban people, to force certain kinds of news into people's hands, to note that the obvious. Facebook is where 60% of people primarily get their news now. Google is where people get news now instead of reading physical newspapers, which still exist. The tech titans, like titans of the past, some are perfectly respectable, honorable people, some are not so. This is not a new phenomena. And it's not a trivial phenomena. I don't make light of the challenges we face, particularly in the news and information domains. But the areas of our economy that have been impacted by, to put it in the sort of simplistic terms, digitalization, are almost all information-centric areas. Entertainment, news, and finance have been primarily impacted by the cloud and digitalization. Those collectively constitute under 20% of our GDP. Most of the rest of the economy is very lightly touched by digitalization, by computing and clouds. That's because it's harder. It's easier to add information features to information systems than it is to physical systems. We're still a physical world with physical systems. The things that matter in our environment are physical systems. We're impacted by atoms. We're not impacted by bits. The bits inform the atoms. So I've focused on both those subjects in my book. I'm not a Pollyanna or naive about the negative forces of technology in terms of warfare or in terms of malfeasance and misbehaviors by those who are either smart or fortunate enough to gain some of the early benefits. But I'm nonetheless optimistic because this is a revolution that's in its early phases and we're fighting some of the side effects, which has always been the case. Let me paint a picture of what the good things are rather than explain away some of the challenges. At the core of the reboot of the information part, the three spheres of information, machines, and materials, at the core of the reboot of the information part is the emergence of a new class of logic engine, which we call an inference engine often. These are microprocessors that don't compute, but they infer or estimate. And this gives us the vaunted or feared class of logic called artificial intelligence, AI. AI, aside from its nomenclature that sows confusion, is still in early days. AI is a new thing, not a replacement. It's both additive and complementary to existing computing. Let me give you an historical analogy from the 1920s. And we saw the same kind of phenomena in the emergence of both the automobile and later the jet engine. Both were based on the same underlying materials in combustion technology and knowledge, but they yielded very different kinds of services. Similarly today, the many and sort of ingenious classes of logic engines are realized over an incredible range of physical size and power, from flea speck size, literally, and smaller, to dinner plate size microprocessors, and have computing power that ranges from the ability to imbue a tiny part with locational awareness or give a machine sort of a mainframe capability by itself. These microprocessors are obviously, as I stated, the building blocks of the data centers that are what I term the cathedrals of commerce of the information era. The smart sensors that you've heard people talk about are the flea-speck-sized microprocessors. The inference engines that are in your phones now that help you do things like navigate, order food, DoorDash, Uber, these are all inference engines that do complicated relationships that matter to take friction out of society, make things easier. Most people prefer those conveniences. They have challenges in integration, but they've taken friction out and increased productivity. Those kinds of productivity gains are now becoming feasible in the more challenging parts of our economy, including what's been in the news a lot these days, the supply chain. But nowhere is the meme, "This time it's different." Probably the 4 most dangerous and silly words in the lexicon of the English language, or most misunderstood. But nowhere is that notion more miscast than with the fears of the power of AI. It's been promulgated by the dystopians and the intelligentsia. I won't name names. I will later, but no. It's true, AI is different. An AI-enabled supercomputer is as different from your desktop PC as a 1977 Apple IIe was different from an abacus. Profound difference in power, capabilities, and implications. I can't begin to do justice to dissecting the trope that AI is a destroyer in a few minutes. But I can crystallize the essence of a kind of category error in this debate by noting the nomenclature problem itself, artificial intelligence. It's, to put it simplistically but accurately, roughly as informative as calling a car an artificial horse, calling an airplane an artificial bird. When it comes to artificial intelligence, we're miles away from fully understanding, never mind emulating, what constitutes actual general intelligence, biological intelligence. Robots that can drive a car, by the way, can't play chess, or vice versa. But specialized virtual robots, AI in the cloud, can help make everyone more expert in their jobs, whether it's in healthcare, for example, or in environmental protection. So coming back to the great rebooting, in this case, let me focus on the second domain, the one of machines. The obvious iconic example of something that is profoundly different, that's hidden in plain sight, but you don't see them every day, are the class of machines that fabricate the microprocessors themselves. They operate at the atomic and molecular scales with great precision. It's a kind of manufacturing precision that's utterly unprecedented in history. Those machines are how we produce silicon microprocessors, chips, we've come to call them, right? Like computer chips. We could produce them at such great volume that you could count them literally by the kiloton. That's a class of machines, though, that's now migrating into other markets, revolutionizing the manufacturing for all manner of things like that are biologically useful, like biological sensors. You can imagine, to just give you an example, in environmental domains, so-called smart dust spread on agricultural fields to optimize the use of water and fertilizers, obviously an environmental benefit. In the machine domain, there's also the maturation, finally, after about 2.5 decades of hype, of the quasi-magical 3D printer. That constitutes another in the new means of production. I think you probably all know what that is. It's a machine that can essentially take a computer image, an idea, and directly print the part. It sort of brings on the age of mass customization, not just mass production. What's arguably more consequential about 3D printers is that they mimic how nature grows components. That means that we can fabricate things not just more efficiently, but we can literally build things that are impossible to do with conventional machine tools. Like, for example, printing human organs, which is not fanciful. Again, the part of the magic Google machine that's useful, Google, Dean Kamen, and organ printing. He's far more bullish than I am on the prospects being realized within a few years, but I certainly think it's emerging within this decade because the technology already exists. It was not invented today, but it's being perfected and maturing today. Also in the domains of machines, we're now reaching a useful maturity for the impossible to ignore drone, and before long, the air taxi. The latter, of course, is usually derisively called a flying car, and it's derisively called that because it's been overpromised for as long as there have been cars. In fact, Henry Ford in 1940, the original Henry Ford, predicted firmly that flying cars were just around the corner. But like so many other things in the worlds of atoms and not bits, ideas are old, but realizing them in the physical world can take a very long time. That was the case for flying machines, of course. As you all know, they were imagined by the Greeks a very long time ago. In fact, the Greeks also imagined something that we now term an anthropomorphic robot, a robot that looks and walks like a human. And of course, anthropomorphic robots are a staple in dystopian fiction, The Rise of the Machines. I mean, who doesn't love Arnold Schwarzenegger playing a robot? It's great. But today, you don't have to wade very deep into the parts of the YouTube they'll let you still play in to find videos of practical anthropomorphic robots that are actually real, potentially very useful, still a little too expensive, still not quite as effective as they need to be. It would be kind of like looking at, if they existed, videos of the first cars, the Durea wagon, the first automobile in the United States in 1893. Clunky, nothing like what you drive today, but we knew that a Model T moment was coming, and it came less than 20 years later, and the auto age took off. We are on the cusp of a Model T moment for an anthropomorphic robots in our 20s. It'll be quite remarkable, and odds will be that it'll be an industry as big as the automotive industry. Finally, the third domain, materials domain, is the one that gets ignored because it seems boring. It's materials science. What's going on today, however, is comparable to what kicked off the 20th century with the advent of chemistry. Prior to chemical revolution, prior to chemistry, which is, of course, since been vilified, everything in society was built from natural products. Wood, bones, leather, stone. There were no synthetic materials. It doesn't take any imagination to look around your daily life, to look at the fact that, yes, we still use stone and we still use wood, but the quantity and nature of products that exist from synthetic materials exploded after the chemical revolution. And it didn't explode because the chemical industry was pushing it on citizens. Because the materials were so much better, so much definitionally, and to use the economist term, productive, and enabled new classes of things that were impossible before, like pharmaceuticals. Instead of magic potions brewed up in sort of a witch's cauldron. The revolution we have before us now is in something that you could call smart materials or computationally designed materials, based on a phrase that has been coined some years ago called the materials genome. Instead of thinking about the science of materials now, engineers can essentially do what alchemists dreamt of for centuries. They can conjure up materials instead of vats of steaming chemicals in silico, in supercomputers, using algorithms that can test and try out new classes of materials that are designed to meet a specific property or outcome, and yield properties that are remarkable. Self-healing materials, self-cleaning materials, so-called metamaterials that exhibit properties that don't exist in nature, like invisibility. And the invisibility material does exist. It's just not practical. So again, an example of a material that's been invented. It's not practical. It hasn't matured, but it's in the invisibility features of it that are interesting, by the way, are things like acoustic invisibility, make places quieter, radar radio invisibility, to remove radio noises that you don't like, which would be signals to cell phones, for example, when they're inconvenient. It's in the revolutions in the material domain that we'll also find the magic catalyst that one day will cheaply desalinate water or make hydrogen cheap. The other sort of class, to finish with the materials revolution, and there are many other examples, are in bioelectronics. These are electronics that are biocompatible. The kinds of core materials needed to do that, many of them have already received FDA approval. What that would mean, in effect, to put it in sort of, sounds like trivial terms, is you could swallow a computer, a consumable computer, small enough to fit in a vitamin pill, and you have it every day when you have your vitamin. Why would you want to do that? Well, if all of us have had this experience, I think. You go to a doctor, you don't feel well. The first thing the nurse or a doctor asks you is, how did you feel yesterday? Do you know what your blood pressure was 2 days ago? What did you eat 2 days ago? What was your blood sugar level last week? No, I don't know what I ate this morning, maybe even a half an hour ago, I'm not so sure. These are questions that are clinically important and valuable. You will, in the 20s, be able to collect that class of clinical information in real time, stored securely on a body-centric network that your physician can access when you find it clinically useful. These are meaningful changes in the efficacy and productivity of healthcare coming about in the main because of a convergence of a materials revolution, which will link with the information revolution and be amplified by the power of AI-driven inference engines, because some of the outcomes, some of the questions, some of the answers are not black and white, they're inferential. So I'm gonna sort of come back to the big picture on energy, because the environmental piece is an energy piece. And state, again, something that's obvious as soon as I state it. On the energy producing side, because everything I've described so far is energy consuming, 99% of what you need and do in life is energy consuming. You consume energy. Your machines consume energy. Services consume energy. Healthcare consumes energy. One could calculate the energy costs of producing the viruses, the mRNA viruses, and I have. And the energy costs of producing the mRNA viruses were stupendous and amazing. And would we not have done that because it consumed energy? Should we have saved energy to avoid the production and development of the supercomputers that accelerated that really remarkable revolution? It wasn't warp speed that was created overnight in words. It was a technology that was developed over the last decade. So in energy domains, what we can do is derivative from exactly the same three spheres: the kinds of information we have, the kinds of machines we can build, and the kinds of materials that are available. Since a more prosperous future will a priori consume more energy, then I would redound to a politically convenient phrase uttered by a former president, which is entirely accurate, that a future will need access to energy from all of the above. We'll need more of everything. It's not a transformation or a transition, but rather an expansion, an acceleration of our capacities to produce energy for society. And in talking about energy, I'd be remiss if I didn't say something more explicit about climate change. It's the epicenter, of course, of so much of what's going on in policy. It is, in fact, the animating part of the Great Reset. As you all know, that's the whole point of the whole idea of abandoning, transitioning from, and banning hydrocarbons. So I'm not going to take on that debate. It's too late at night, but let's just stipulate that the climate has always changed, and it's going to change more in the future. The thing I think we should keep in mind from the viewpoint of what will really matter to humanity is that, and not to trivialize it, but to state something that sounds silly, but it's true. Nature, our environment, nature's been trying to kill humanity for all of history. Everything we've done about technology is to improve our capacity to survive in the face of everything that nature assaults us with. Not just storms and the weather variabilities and floods, pathogens, but nature is a predator when it comes to life on Earth. Having sufficient wealth to put technology to work for greater resilience for an ever larger number of people is the central miracle of the 21st century, and it will be the central miracle of the 21st and 22nd century. So I want to wrap up, sort of give you maybe an apology for being an optimist. My book is an optimistic title. My thesis is optimistic, even though I'm not naive about some of the predatory destruction with some policies that are being promoted and the amount of spending we're having on destructive policies. And it's difficult, it's a pretty tempestuous time in the aftermath of both the human and political carnage that the great lockdowns inflicted on us all in the world. So, sorry for being an optimist in the middle of it all, but we have problems. I'm not trivializing them. I'm not naive that the world is filled with political and social problems. I don't have to dwell on them because the new and old media do an obsessively good job at that. But what I'd like to say, just for context, is I don't believe that a reasonable view of history would suggest that our problems are significantly greater in either magnitude or character from what we've had to face before. Since I picked the 1920s as my benchmark for the last great technological revolution, for perspective, let me remind you, and there's probably historians here that know much more about this than me, so I confess I refreshed my history reading for my book, which is what you do when you write a book. You read a lot, too. So 1920s, the roaring 20s, right? What was going on? Obviously, we just exited a horrific war. It was, by all standards, a horrific war. We'd also just exited, as you all know, the 1918 pandemic, which stretched into the 1920s. And it had a per capita death toll that was 400% higher than what we've suffered through in these last 18 months. 1920, most people have forgotten because we weren't around, it began the third deepest recession in the 20th century. And it lasted into the summer of 1921. The politics of that day, well, this was the beginning of the Red Scare, the fears of communism, and they were realistic fears of communism infecting America at that time because the Bolshevik Revolution was only a couple of years behind us. It was a rise of Lenin. And to give you a sense of how seriously that was taken at the time, and to staying on its history, the New York State Legislature, which was the biggest economy in the great states of America in 1920, the New York State Legislature expelled 5 duly elected legislators because they were members of the Socialist Party. The newspapers of that day celebrated that with headlines. One of them said, "This is America, not Russia." Sounds kind of familiar. Roaring 20s, massive labor strikes. Cities were brought to a standstill all across the country. Mayors deployed thousands of police and federal troops. Anarchists were exploding bombs all across the country in coordinated attacks on police stations. Wall Street had the third biggest terrorist hit in American history. On September 16th, 1920, killed 36 people on Wall Street from an anarchist bomb. The nation also saw horrific race riots, hundreds of whites and blacks killed. Martial law was imposed on Charleston because of the race riots. Martial law. The 1920s was also the rise of one of the most profoundly odious scientific movements in history, the eugenics movement. It was a settled science of that day, widely embraced by the prominent intellectuals of all kinds and all the major universities, all the storied universities of that day, all of the Ivy Leagues and all of an intellectual class. It was a grotesque idea. The 1920s was also when J. Edgar Hoover told the president in early May 1920, that May Day, there would be a violent uprising. And there wasn't. The election of November 1920, that's when Harding was elected on a platform of return to normalcy, which is kind of interesting. You probably all know one other factoid of the election of 1920. It was the first time that women could vote. Constitutional amendment, which, in the perfect lens of hindsight, is shocking today, if you read about it, to know how controversial that was at that time and divisive it was. The 1920s had social unrest, not least because of prohibition. Another constitutional amendment, 2 constitutional amendments in 1 year. They banned something that human beings have consumed since before written history. The ban stayed in place for 13 years, just as a calibration point for how sticky government malfeasance can be. There were epic anxieties then about wealth disparity. The storied mega mansions proliferating around the Long Island Gold Coast. It was also a time of right near the apotheosis of the newspaper era. There were 20,000 newspapers in America at that time, over 20,000 newspapers at that time. In the competition for attention, well, many papers did what we came to label yellow journalism, and they were filled with, and you'll excuse the modern expression, fake news. In fact, in a piece of relevant historic context, in 1925, an instance of fiction posing as news triggered the Minnesota legislature to enact a public nuisance law. That law empowered a single judge, without a jury trial, to permanently cancel a newspaper's ability to publish. It was 6 years before the U.S. Supreme Court took that up and novated it in a landmark freedom of press case. and it prevailed by one vote. The point of this history is that whole period is fascinating to read. The 1920s is a period of American history. As my friend Steve Forbes said, it also had something else going on. The biggest tax cuts in history, the biggest deregulations in history. That also helped fuel the great boom, because it was the good fortune of having that happen contemporaneous with the efflorescence of technologies that the boom took off. He would also point out, he's got, I guess, a documentary coming out on Coolidge, that Coolidge had to fight the Republicans on tax cuts and on deregulation. More regulations and more taxes were de rigueur of the day in both parties. The point of this is a truncated history, and not only do I apologize for being an optimist, the reason I'm an optimist, if you think about that history, it tells us something about our future, especially our technological future. Obviously, America survives that tumult, right? But in the Roaring '20s followed, their Roaring '20s. And it was a jazz age, literature boom. Agatha Christie started writing The Great Gatsby. It was really a remarkable pivot in every respect culturally, and it propelled the next 80 years. I know, again, sidebar, the 20th century wasn't all wine and roses. This is, again, to use the Gen Z's technical term, no duh. The Roaring '20s ended, it stopped the roaring, and the stock market crashed in 1929. We had a depression, another horrible war. But to repeat what I told you earlier, by the year 2000, the average American was living 30 years longer, and real wealth had increased per capita by 700%. A remarkable boom. Whenever one thinks about today's troubles, a casual reading of history, you don't have to be a historian to tell you that this time it's different. Doesn't quite cut it. Of course, what's different is our technology opportunities. They're similar in character, different in their specifics. So let me finish by saying, yes, one of the most important things about this institution, and others like it, and there aren't many like it, is that it helps instill and maintain the values that are relevant to the underlying nature of this country. This is why we America, benefited from the technological boom of the '20s more than any other country in the world. Russia managed to Sovietize its economy. They did not benefit the way America did, not because they didn't have the same technology access, but because they destroyed their political system. It is possible to Sovietize an economy because it's happened. That's why we have to fight for it. It's vital to ensure that America remains a country of fundamental freedoms, opportunity, and equity in the original sense of that word. But those aren't the features that alone explain the incredible expansion of prosperity, comforts, conveniences, and wealth that we've seen. The prime driver, say it again, it was a simultaneous and fortuitous convergence of revolutions in technology's three core domains. Far more environmental justice will come in the future for a world that has far more surplus wealth. And that's the wealth that will come from the services and products, from the combination of the revolutions that are being yielded now in our time in the same three core domains. And with our iconic technologies for our time, of course, is in fact the cloud. It is AI. It will be the robots and things that we'll call smart materials. We may change the word later, who knows. All that will do far more good because of the wealth for far more people than will heavy-handed mandates and regulations trying to deploy more of yesterday's technologies. So let me just close by saying that while I haven't focused on it, getting the politics right matters. I worked in the Reagan White House, as you heard in the introduction. It was a great education for me as a young kid. I was 5 years old, just want you to know. I'm not that old. I told my kids I was 5 years old when I was in the Reagan White House. They believed me till they were 5. Politics matter. It always matters. Krauthammer said that a lot. He said that's why he left medicine to become a political journalist, because if you don't get the politics right, the other stuff doesn't matter. So I'm not naive about that, but the reason I wrote this book was that I also think it's important to have a sense of optimism about what's possible, to know why we're fighting the political battles, that the wealth expansion is what we want to make sure happens, because it'll bring all the other benefits, or help us bring all the other benefits that everybody wants. The rising generation now, the so-called Gen Zs, it's fascinating. Gen Zs are beginning to enter the workforce. They actually live at the most exciting and prosperous, potentially prosperous time in history. I think the next boom will be bigger than the boom of the last roaring 20s. So there's a lot been said negative about my generation, the boomers, who are now receding. It's our turn to fade into the distance, slowly, healthfully, I hope. Much of the criticism is deserved, but I think we're handing off a pretty exciting and promising legacy, frankly. We have political battles to fight, but we have a technology opportunity that is literally unprecedented in human history. So for the rising generations, I like to paraphrase the famous line from Ben Franklin. It's an exciting future if you can keep it. Thank you.
Thank you. Mr. Mills will be signing copies of his book, The Cloud Revolution, How the Convergence of New Technologies Will Unleash the Next Economic Boom and a Roaring 2020s, in the Searle lobby following the lecture. We now have time for a few questions. If you have a question, please make your way to a microphone. Please note that student questions will be given preference.
Hi. What would your response be to the concerns raised, in previous lectures and during the CCA of surveillance being sort of, I guess, what is different, like, the tech giants, the aforementioned tech giants, as well as that working with government as a legitimate, like, a unique new threat to liberty and progress in the future. How does optimism remain in light of that?
Well, there's two answers. One is, again, history's context. So we look at different times in history about technologies and their surveillance potential. One of the most interesting ones to look at is directly analogous is what people thought about the camera. It was considered a destructive force, would destroy the legal practice. There's an excellent Yale Law Review piece published in I forgot the date, late 1800s, decrying a use of photographs as evidence. You can imagine where all that went. So you say, well, but this time it's different. Yes, it is different when Google tracks me on my phone. I would say that what's different this time is this. The technologies that exist today in the information system that make it easier to track you also make it easier for you to protect yourself from tracking, except in a Sovietized economy, which is, again, this sort of combination of things we have to worry about. The tech giants, and Apple's probably been best on this on average, know that if they don't provide a lot of citizens with the kinds of security and protection that they want, that somebody else will, because it can be done. So I would just say, without digging into it, the technological capacities to give you a lot of privacy and security exist. To allow you to opt in to, we'll call it voluntary surveillance because you want it for your health, rather than to have it done surreptitiously, for you to be able to detect when it's being done to you. And if the tech giants don't offer those technologies, upstarts will. People think that Google and Amazon will never be dethroned. I invite you again to look at history and ask, well, IBM had 78% market share in computing in 1977. We can go back to the peak eras of steel or rail. So the giants are a giant for a while. Some of them last a long time, most don't. New technologies displace them. So I'm worried about what they're doing, and they're misbehaving, a lot of them. But I think they know they are. And what they have to worry about is the same thing we have to worry about. They have to worry about the regulatory state. Because if a political movement happens that decides to come after them and becomes a supermajority in the House, Senate, and have a White House, then they're on the wrong end of it. What happened to the great companies the last time trustbusters came along was that they broke them up. The government has a lot of power, and it's not necessarily the case that they will be the favored children. And we already see evidence that they're losing some favor in even their own democratic circles. So it's a long answer to a really important question. Technically defeatable, politically critical to make sure we don't naively let ourselves drift into a surveillance state, which is the direction a lot of statists would like to take us. But that's been true forever.
All right, question to the speakers left.
Thank you for coming, Dr. Mills. I have some serious umbrage with your speech. You have come...
Umbrage is good.
Yeah, of course. You have come to Hillsdale and stood up on the podium and said in favor of a technological revolution, a great reboot, which I would just call a reflavored great reset. You've talked about microchips in people's bodies, mRNA vaccines without test procedures or in made quick time through computing, and you've talked about a lot of things that the Great Reset people would very much love. Mm-hmm. Why are you different?
Well, let's be specific, but you're absolutely right, because what you're capturing is a convergence of the two challenging areas, which is what people do with technology, what our government says and does versus what the scientists and engineers are doing, and what the media says about these things. So I was very careful in my language about the mRNA vaccine. It is a technological tour de force. It is, in my opinion, offensive, inappropriate, and dangerous to have deployed and pushed vaccines of the specific vaccine the way they have, the government has, to be disingenuous and duplicitous about issues and problems and side effects. This will go down in history, and we'll look at it as a case study that we're the guinea pigs in. Doesn't change the fact, however, that these are phenomenologically important kinds of vaccines are one of the miracles of the 20th century and the 21st century. Having better vaccines produced more quickly, carefully, with the kinds of boundaries we want. So this is where we get into this Faustian bargain problem. The way in which we develop, especially medical, dogs get location chips injected unknowingly below our skin. I mean, this is, we can do this to animals. But what I was describing is a medical device, a consumable device that allows you to measure your blood sugar level, let's say. So it's not implanted and it's voluntarily. But again, same point. You're absolutely right. So the fight of your generation and where conservatives, in fact, I have a son, I have several sons, 3 sons, and a daughter. So our arguments about these things are very similar. And so what the conservative movement has done is it has failed to continue to prosecute the argument about why free markets and conservative principles matter and why that gets us to transparency and not perfect outcomes, but better outcomes. So we've lost a lot of the younger cohort. A last survey I saw shows that 50% of millennials, 50%, pretty close to that, think socialism is a better model than capitalism. This is terrible, right? We know it's not a better model. We failed to promulgate and argue that case. These are related but different phenomena. What I'm trying to paint is a picture of what the opportunity is, but we can run the risk of letting our country go where the Soviet Union did in 1918 and 1920. Their per capita wealth didn't go up, a fraction of ours. The people lived under dystopian conditions. They're smart people. The Russians are nice people. They're creative people, but they really got the short end because they picked the wrong political system, in a sense, right? I'm an immigrant, former documented alien, Canadian, now American, and I would tell you that in my study of history, the one thing that I think is true, this is where my optimism comes from, is that you exhibit something that I came here for, which is that the American culture is different than Canadian culture, different than Australian, British, and Russian culture. Whatever it was that, and this is what Phelps writes in his book, Mass Flourishing, which you should read. Why did America benefit? He was asking the question, the technology revolution that came along over the last century benefited America uniquely. It's unequivocally the case. It's indisputable. His question was why? And the book is essentially a disquisition on culture. It was the nature of our culture that we didn't, and he goes through a lot of the kinds of problems that I highlighted. It's not that we didn't have to fight these fights and that they weren't easily won, they weren't won overnight. So I'm here because of two things. I'm optimistic that the Hillsdale kind of model is beginning to take hold. It doesn't have to convert everybody. You don't have to have a revolution with everybody agreeing with you. You just have to have enough people to begin to push back. This is a kind of place where that happens. But I think it's very important to understand that the opportunity is to have the wealth expansion is remarkable, and this is what everybody fights over. You know, healthcare is expensive, right? So everybody, but who doesn't want healthcare? So we call it a cost. It's not a cost, it's a need, right? But you want a doctor telling you what you have to do? No. Technology will give you much more power over that than the state. So anyway, you're absolutely right to have some umbrage if you thought I drifted into tech land where I'm endorsing all of their misbehaviors. But here's the problem. The technologies that they're either creating or writing because other people have created it are precisely the technologies of freedom too. They are the technologies of freedom. Printing press was the technology of freedom. When the internet first started, everybody thought it was a technology of freedom, and they were right. So we have to get the regulations right on that too. I worry that conservatives and liberals are going to get together and regulate the tech sphere the wrong way. Not that they don't have to have, let's just say the obvious. Once you become a platform for news, that people get their news primarily from you, your platform, you become a utility. This is not good. But thank you for the question. You're spot on. We have to fight these things.
We now have time for one more question.
I apologize if this is a bit repetitive, but I had this so nicely written up from the beginning. But I wanted to focus a little bit more on what you said at the beginning, especially about natural resources. So I just said, given the broader context of this seminar and the points raised by previous speakers this week, your optimism about technology and its effects stands out. You described yourself at one point as having faith in technology, and others here pointed to the impossibility of a great reset without advanced digital tech in particular. And in their skepticism, they join ranks with notable intellects such as Martin Heidegger, who feared technological destruction of authentic human life by revealing the world as standing reserve, nothing but resources to be put to work. Mm-hmm. Do you not think that, given the current political and social climate, we ought to take a more skeptical stance towards technology generally, especially in our efforts to thwart the Great Reset?
Well, sure. I mean, the short answer is yes. We should be very skeptical. But we have to be careful of words. So technology typically means to people today computers and Facebook and Google. That's what the word has come to mean, and that's a problem because that's not what technology is. So that part of technology, the information part, is the part that's grown fastest first and requires and is undergoing deep scrutiny. I would say, as much as all of us are probably quite unhappy with what we heard just before dinner, that YouTube can ban or cancel videos from Hillsdale or Prager or any conservative they don't like. That's obviously a problem. But first, let's be clear, that's not technology. That's not how technology progresses. And I quote David Nye, who's a great historian, and he wrote a really good short book 15 years ago called Technology Matters. So it's a book that's informative and skeptical. It's short, but what he begins with is pointing out that to develop technology is in the nature of humans. That's what humans do. It's wired into humanity. So what we should be skeptical of is how they misuse it, obviously. And that's, again, I'll just repeat, this is why the political part matters. It does matter. It matters enormously. Figuring out what constitutes a monopoly and how to manage scale is not a new problem, especially in a modern society. We're now revisiting it because we have all new scales of new classes of industries. I don't think we need any new, personally, I don't think there's any new case law needed to deal with scale and intrusions. What's needed is a political structure or political actions that are appropriate to the laws that we already have. But sometimes that requires you to write a new law. So yes, look, it's a lot easier to write about what's wrong with the world and what's wrong with our country. And there's always something wrong, and there's always misdirection. And it's not that I think that we get through the difficult things passively. the world happens to get better because bad things are happening. Obviously, people have to be warriors and fight it. That's been true over all of history. What I'm saying is I have a lot of faith in the fight that's underway. I think there's a lot more progress being made in the political fight than is necessarily obvious in the superstructure. There was some evidence of that in this recent election. We'll see what the next election feels like. But the culture wars matter. We had culture wars in the 20s, and it's easy to suffer a sort of it's a mental disease, not you, I mean, it's a collective disease of presentism. You know, our problems are different than the problems in the past. They're more difficult. They're very, very similar. But every time it takes fighting and skepticism. So I agree, but I refuse to believe that the future is dystopian. It's much more fun in fiction to have dystopia, but the fiction may, like Orwell's 84, we've seen elements of it become true. So now we're unhappy about it. We'll see. I mean, again, it would be obvious that one can't guarantee America will be a great country a century from now. But I think all the indicators suggest that is the case, but we have to fight for it. That's why I ended with Ben Franklin. It's not going to happen passively. The way I'm fighting it, by the way, is I think it's important to, we can't, the people who are villains, but you can't vilify everybody that's in the tech community for the infrastructure and machines that they built. They're not all evil. They may be naive, we may disagree with them. And it's that character of debate that is again the nature of what we have to fight and have been fighting before. I'm hoping, maybe naively myself, that since I am a tech bull, that maybe some of my tech friends who I know a lot of will see the wisdom of, we'll call it a Hayekian approach to what the future of technology should look like. Not all of them will go there, but we only need 10%, and that's an army.
Thank you, Mr. Mills.
Thank you.